Okay, lesson 4.3, part 2, more with the unit circle. So working to learn more about the unit circle. This is kind of our last big focus lesson to go through and learn about the unit circle. From here on out, it would be using it then. But, it's knowing how to use it. If you notice that first section, it says finding the trig functions of angles based off the basic three. So the basic three we're talking about, your chart over there. Your chart you're supposed to know, okay, part of the whole point of memorizing it is 30 degrees, 45 degrees, 60 degrees. Those are your basic three. Lots of what we do in trig go back and refer to those basic three. So if you know those basic three, you can find a lot of basic information, okay? And that's what we're looking at today. So there are a set of 4 steps up top there that I'm going to kind of use. Once you get used to it, I don't really feel like you'll need those 4 steps. You'll just know what you're doing. But while you're trying to learn, the steps kind of give us, okay, we've got to check this, So we look at those steps real quick. Number 1, notice it has RA beside it. Find out the reference angle of the given angle. So we worked with finding reference angles already. We've already done some of that. Remember reference angles? When you're looking at reference angles, it's how close is it or how far away is it from the x-axis, right? What is the angle that the angle in question forms with the x-axis? So maybe it's how far above or below 180 it is, or how far from 360 it is. Just depends on which quadrant it's in. So first thing is going to be to find the reference angle, and that's when you're adding or subtracting either from 360 or with 180. After we do that and get our reference angle, and the whole point of a reference angle is your reference angle is either probably going to be 30, 45, or 60 in this situation. After we do that, we're going to need to figure out what quadrant the angle is in. Now, as in, yes, quadrant 1, 2, 3, and 4, but also, do you remember we had that saying, all students take calculus, or Amy Sargent teaches calculus, however you want to remember it, but knowing what happens in each quadrant, right? And so we'll talk about that. Step 3 is write out the answers to the trig function based on the reference angle. So if it's, sine of, I came up with a random number I'm not necessarily using. If it's sine of 330 degrees, well, is that on our chart? 330 degrees is not on our big 3 chart, is it? But it's going to have a reference angle there. And so we'll write out the answers based on, if our reference angle is 30, we'll write out those answers. And then step 4 is putting the proper signs on it based on the quadrant. So, is it positive in that quadrant or negative in that quadrant? Okay? So those are the steps we're going to go through. The big thing are figuring out the reference angle and the quadrant. Once you know reference angle and quadrant, that's the gist of what you need to know. So let's try example 1. Find the 6 trigonometric functions of 315 degrees. So, do you know sine, cosine, tangent, and all of those of 315? Is that something that's on my chart over there? No, that's not one of my big 3. Which means, if we think step 1, we need to find our reference angle. So where is 315 in relation to that x-axis? And let me remind you, if you guys remember the reference angle, forgot to mention this earlier, has to be an angle that is between 0 and 90 degrees. Do you remember that? That's the reason it's, you're adding or subtracting from 180 or 360, depending on where it's closest. Okay?
So you could do 360 minus 315 reference angle.
Okay, well, does that make sense? Where's 315 closest to? 180 or 360?
360.
It's closest to 360, yes? Because if you think about 315, here's what I know. It's more than 270, but it's less than 360, right? Because at this point, I would like to think that you guys know what each of the axes are, right? That it's 0, 90 degrees, 180 degrees, 270, and then 360. I would like to think you guys have a basic grasp of that. And so step 1 is to find that reference angle. And as I said, that's when you are adding or subtracting 180 or 360. If 315 is closest to 360, then, yes, I agree. We want to do 360 minus 315 degrees. What is 360 minus 315 degrees? 45 degrees. Well, I will say that makes me feel confident I'm on the right track because 45, it's one of the 3 in our chart, yes? So that makes me feel like, okay, I must be doing something right here because I've got something that is a legitimate reference angle between 0 and 90, and it's also one for my chart. Okay, we've kind of already talked about this, we just haven't specified. Step 2. What quadrant is 315 in? Yes, it's in the 4th quadrant, which, what is important to know, and we're not going to use this quite yet, but what is important to know about 4th quadrant? Okay, all students take calculus, or Amy Sargent teaches calculus. That's the C quadrant, so that means cosine's positive and it's reciprocal, secant, okay? So cosine secant will be positive, everybody else will be negative. And I'll give you a little visual here. And at some point you'll be able to do this whole reference angle bit in your head. But so 315, we can agree is down there, yes. We've already talked about this, but just write it out. That means it's closest to the x-axis at 360. And thus we did 360 minus 315, which was 45 degrees. We also talked about our quadrants. All students take calculus. And so that's going to help us with step 4. Questions at this point? Because I'm going to tell you guys what, this whole reference angle business, incredibly important. Okay, incredibly important because as we go through with trig, this will become something that it's expected you can do this. Okay, it's something that, will just automatically be thrown in problems. And I talk about that in pre-cal. When you get to calculus, it's expected knowledge. If you don't take calculus with me next year, but you take calculus in college, guess what? It's expected knowledge. So you have to know some basics of trig there. We don't do a ton of trig in calculus, but it does get randomly thrown in. Okay, step 3. If you look at step 3 up there, it says write out the answers to the trig functions based on the referencing. So when I go through and ask you, what is the sine of 315 degrees, we're not really going to think 315. We're going to think what? 45. So I'm going to tell you on this step is think 45 degrees. Even though I'm not going to necessarily say 45 degrees, we're going to think 45 degrees. So, if I ask you, and we're just using our chart right now, the sine of 315 degrees. I'm saying, what is the sine of 315 degrees? You should be thinking, what is the sine of 45? What is the sine of 45?
1 over square root of 2.
Okay, so you can say 1 over square root of 2 or square root of 2 over 2. Officially, I'll take either or. My preference in this situation is the square root of 2 over 2. Okay. Now I'm going to ask you for the cosine of 315 degrees.
Same thing.
Okay, so cosine of 315, what you're really thinking is what is the cosine of 45? We know sine and cosine of 45 are the same. So they're square root of 2 over 2. tangent of 315 degrees? What? 1. In other words, the tangent of 45 degrees is 1. Once you have the first 3, what do you know about the next 3? Reciprocals. Reciprocal function of sine is cosecant. So cosecant square root of 2, right? So here, if I use the idea that sine was 1 over square root of 2, the reciprocal is square root of 2. Reciprocal function of cosine, secant.
So this is where the chart really helps. Since all those things.
Secant of 315, same as cosecant, square root of 2. Reciprocal function of tangent, cotangent. Cotangent of 315, 1, because reciprocal of 1 is 1. Step 4. Put the proper signs in front of the answers based on the quadrant. So we already talked about which quadrant is this in? Quadrant 4, which for trig functions, it is the, okay, it's the cosine quadrant, right? It's the calculus quadrant, so it's C for cosine. So what's that say then? Cosine is positive and its reciprocal secant is positive. Everybody else is negative. So negative sine, negative cosecant. Negative tangent, negative cotangent. With a little practice, you'll be able to do that all at once. You won't have to break it down step by step so much. But if we would have just gone into that, trying to do that all at the same time, it wouldn't have gone well. So. Okay, questions?
Wait, what was the step 4 part?
We put the positives and negatives on. Or we left the positives and we put the negatives on. So I wrote 4 negative signs in there. Okay, so that's your practice problem where we have to do all 6. More realistically, when we're doing a problem, it won't be find all 6, but just give me, what's the cosecant of 315 degrees? Just give me the 1. Okay, and so that's what we're going to practice here, is all of these steps for just one answer. So, A, we want to find the sine of negative 210 degrees. So first thing you might want to think, what do you know about negative 210? Where is negative 210? Okay, between 180 and 270, but negative. Okay, so I see what we're talking about in general. My recommendation, can you change negative 210 to a equivalent positive angle? Okay, so if it's at negative 210, or a negative number in general, and we don't want a negative number, remember coterminal angles? Coterminal angles are angles that, same location, but different names, right? So how do you find a coterminal angle for negative 210? We're at negative 210 and we want to get to a positive version. How do you go once around the circle? 360, right? So my recommendation for a beginning spot is to take negative 210 and add 360. And get us to a point so we're not hesitant or unsure or trying to convert negatives and positives. So what is negative 210 plus 360? 150 degrees. Okay. Are we more confident of which quadrant this is in? Okay. So now, when I say sine of negative 210, that's also the same as saying the sine of 150 degrees. Is 150 degrees on my chart over there? No. On that chart, not on the unit circle. The unit circle doesn't tell me anything. Is it on my chart? No. So we need a reference angle. How do we find a reference angle for 150 degrees?
180 minus 150, so it's closer to 180.
Okay. So do you guys understand? Think about where is 150? It's past 90, but before 180, yes? So it's closest to 180, not 360. So we're going to take the 150 and subtract it from 180. What is 180 minus 150? 30 degrees.
If it was to between 360 and 90, I guess you wouldn't have to subtract anything. So
It'd already be 0 to 90. Yeah. If it's, and really don't think between 360 and 90, think it'd be between 0 and 90 at that point. And so, it'd already be in a reference angle. Okay. So, instead of sine of negative 210, we're going to think, what is the sine of 30 degrees? Sine of 30 degrees, according to my chart, is 1/2. Add or subtract 360, depending on where you're at. Yeah. If you have a number that is either negative or bigger than 360, add or subtract 360. If you have a number bigger than 360, subtract 360. If you have a negative, add 360 until you get to a number that is positive. Okay. Am I done with this problem here? I said the sine of 30 degrees is 1/2. Why not?
Because you have to put the positive and negative.
Okay, we have to decide. Okay, is this positive or is this negative?
Sine is positive.
Okay, which we never officially said. What quadrant are we in?
2.
150 degrees is in quadrant 2. And so, here's my little reminder. You'll see me write that a lot when we talk trig. What do we know is in quadrant 2? That's S. So that means sine is positive and we're done. We already have positive 1/2. Okay, got it? Just to say, you got more room to practice here. Let's try B then. Tangent of 5 pi over 3. Now, I know a lot of you have probably already looked at your unit circle, and that's fine. Long term though, can you figure out what quadrant 5 pi over 3 is without looking at your quadrant, without looking at your unit circle? And without going to degrees. Sorry, I'm going to be real picky here, I guess.
Is it that's 3 by 3.
That's exactly what I want you thinking. Because here's the deal. Are you always going to have the unit circle in front of you? Probably in pre-cal. But once you get out of pre-cal, no, you won't. Okay? So, one of the things that you need to work to become more comfortable with is, okay, how do I figure out which quadrant that is without just looking at my unit circle? Now, the angle in question is 5 pi over 3, yes? So think about all of these, and specifically pi and 2 pi, in terms of what? Thirds. So what is pi if I give it a denominator of 3? 3 pi over 3, yes? What is 2 pi if I give it a denominator of 3? 6 divided by 3 is 2. Technically, if you need to change these, I guess we couldn't really go to thirds, but we could go to sixths, right? You know, we could work to get something. But, to me, I know enough. Where is 5 pi over 3 closest to? It's closest to 6 pi over 3, and it's closer to 6 pi over 3 than 3 pi over 3, so that means it's going to be down here.
Why did you say it's down there? I know it is down there, but what was your reason?
Because it's closer to 6 pi over 3 than 3 pi over 3. It's between 3 pi over 3 and 6 pi over 3, so that makes it on the bottom half. Closer to 6 than to 3.
Okay, I was seeing the 3 pi over 2, and I was just thinking that was part of it.
Well, in that, if we needed to incorporate those for some reason, you'd have to turn everything into sixths and talk that way. Which we could, but I feel like at this point in your lives, you can rationalize that, okay, it's closer to this, so it's over there. Okay? So, if that is closer to 6 pi over 3, down there in what quadrant? We can go ahead and answer that question. Quadrant 4, yes. How do I find my reference angle? When we talk reference angles in degrees, we say add or subtract from 180 or 360. I'm talking radians. No! Don't go degrees! Radians! We're doing this whole problem in radians. We're not going to go degrees. You have to learn the fractions in radians. Period, end of statement. You'll be a better math student, I promise. You guys will hate me for it in the meantime, but you'll be a better math student. Okay? Okay, fine. You want to talk degrees? Here's the question. What would you do, since it's in this quadrant, if you were trying to find it in degrees? You would take this angle and add or subtract from 180 or 360. 360, because it's closest to 360. Okay, so what's that mean it's closest to? 2 pi, which is 6 pi over 3. So what are we subtracting from? 6 pi over 3, which, yes, is the equivalent of 360, but that's not where I'm going to go. Okay? So, 6 pi over 3 minus 5 pi over 3 is pi over 3. So that means the question I'm asking myself is, what is the tangent of pi over 3? What? Okay. Tangent of pi over 3. Same thing as tangent of 60, right? Square root of 3. Then the question becomes, is it positive or negative?
It's negative. I wrote the letters down.
Okay. So, this was quadrant 4. Quadrant 4 is my C quadrant. We're talking tangent, so it's negative. Got it? I will be the first one to agree with you. Degrees are so much easier to understand and work in than radians. However, so much of trig is in radians. It's rare in calculus we see a degrees problem. It's radians. Okay, so the more you learn to work with it, the easier it gets. Unless as much as you guys want me to, I'm going to keep talking to you in radians. Okay, ready to try another one? Next one is secant of negative 3 pi over 4. We'll deal with the secant thing in a moment. Negative 3 pi over 4. Do you easily know where negative 3 pi over 4 is? Some people may. Some people will not.
this kind of problem, since it's over a 4, do we go ahead and say that it's 45 degrees? Since that's pi over 4.
It will, that will end up being our reference angle, but we're still going to have to figure out what quadrant it's in. Okay? But it's also negative.
We know it's not.
Well, so officially, if it's negative 3 pi over 4, remember how do negatives count? Negatives go, instead of this way, they go that way, right? So you can think if you want, and I'm going to go this slightly different, but normally, if we go positively, 3 pi over 4 ends up in quadrant 2. If we go negatively, it's going to end up down here. Does that make sense? And you can think like that, because then you can still figure out, Chandler's idea is right, he says this has a denominator of 4. Is it going to be 45 degrees, or in other words, pi over 4? And it is going to be there. Okay. Now, officially, if that's a struggle for you. Okay, what's the coterminal angle? How do I convert negative 3 pi over 4 to a positive angle? How do I find something coterminal? Take negative 3 pi over 4 and add what? Not quite. What are we adding in equivalence? What is once around the circle? Once around the circle is 2 pi. So what is 2 pi in terms of what's my denominator here? 8 pi over 4. Does that make sense? So once around the circle, we're adding 2 pi, but 2 pi is 8 pi over 4 in this situation. So negative 3 pi over 4 plus 8 pi over 4 is 5 pi over 4. Well, we at least now have something in the positive, right? 5 pi over 4. Let's see. This is 8 pi over 4. What is 1 pi equivalent to with a denominator of 4? 4 pi over 4. So if we're talking 5 pi over 4, where is it in relation to 4 pi over 4 and 8 pi over 4? And rightfully so, it would be past 4 pi over 4, but not anywhere near 8 pi over 4, yes? So does that verify this angle here? Yeah. There is my 5 pi over 4. So, reference angle. How do I find that reference angle so I know I have an angle on that chart? Okay, but again, in case you have other denominators, I'm just trying to, the process here. Okay, yeah. It's closest to our 180 mark, so 4 pi over 4. You subtract these two, yes? 5 pi over 4 minus 4 pi over 4 is 5 pi over 4 minus 4 pi over 4 is pi over 4. And we now have an angle that is between 0 and 90. In other words, it's between 0 and pi over 2. So we're going to think, what is the, for some reason, I just started to write sine, saw the S and just went with it. We're going to think, what is the secant of pi over 4? Now, if you have the full chart with you, you can just look at secant of pi over 4, yes? Oftentimes, I don't have that full big chart in front of me, though. Or that's not the part I have memorized. I just have the first half of that chart memorized. So what also do you know about secant? It's the reciprocal of cosine. So you can also, if it helps, think the reciprocal of cosine of pi over 4. So we usually write it as cosine to the negative 1. And maybe you don't want to think that way. But what my brain's probably going to do, because as I said, I don't remember the first half of the chart. I go to, okay, cosine of pi over 4. Oh, that's square root of 2 over 2. Or 1 over square root of 2. What's the reciprocal of that? Square root of 2. And again, as Chandler kind of showed, everyone's going to think about this slightly different, right? And different problems mean different things to different people. So, one last question. Okay, so I never wrote it down again. Sorry, I think it, but I don't write it down. We agreed we were in quadrant 3, I think. Okay, in quadrant 3, all students take. So tangent's positive, cotangent's positive, everybody else is negative, so this is negative square root of 2. Okay, D when you're ready. You get to go back to degrees for a moment. Enjoy. 240. What can you tell me? Third quadrant. This one's the easier one, right? Because it is past 180 before 270. So how do I find that reference angle?
On the test and stuff, do you just show how you find the reference angle, or like people just know it?
No, not necessarily. You could just write it down. Okay. If 240 is in quadrant 3, it's in this quadrant. It's closest to here, which is 180. The only reason I make us explain every little step right now is because some people will really struggle with this. Some people have it already and they're bored with me. Some people are going to struggle with this all year long. And so the more I can repeat myself, the more I can bore some of you and the more chances I have to get others of you. So 240 minus 180 is 60. So do you know something about the cosine of 60? It's 1/2. Okay. Because it's in quadrant 3, it's going to be negative. All students take. So you've got your tangents positive, everybody else negative. Okay, cotangent of 19 pi over 6. What can you think about 19 pi over 6? Okay, so since we're talking about 6, I'm going to put my pi and 2 pi in terms of 6, right? 1 pi is 6 pi over 6. 2 pi is 12 pi over 6. Now, that means 19 pi over 6 is bigger than 2 pi. So it's bigger than once around the circle. So what should I do? Yeah, subtract off of 2 pi so we can figure out where it is the first time around the circle. So 19 pi over 6 minus 12 pi over 6. Does that get me somewhere? 19 minus 12 is 7 pi over 6. Okay, I can handle that. Okay. Do you like what Isabel said? She said being quadrant 3. Yes or no? Because? Yeah. Yep. Barely bigger than 6 pi over 6. Has to be down in quadrant 3. Okay. How do I find my reference angle then? It is right. I totally lost track of time. I had no clue we were that close. Well, since the bell rang, I guess we will end awkwardly, very awkwardly, and finish this problem tomorrow. I'll have you guys finish this problem at the start of class, I guess. Or after you finish your quiz tomorrow. Okay, guys, prepare for quiz tomorrow. Sorry for the awkward ending.